Good morning, students. Hope you all are fine. In a structure of atom, we are discussing the modern concept of the structure that is based on quantum mechanics. And with the advancement in quantum mechanics, it was able to find out the exact structure of atom in three-dimensional space. And as we had discussed last lecture, that how these various shells of an atom are further divided into subshells, and each kind of subshells have different types of orbitals. So today we'll discuss what are the shapes of these orbitals in a atom. As we have discussed that quantum mechanics eliminates the possibility of well-defined orbit in an atom. It believes in that probable region where electrons can be present. So these probable region where probability of finding electron is 90 to 95% can be drawn in the form of an electron cloud. Means they are not the specific geometrical figure over there. They are just area or the three-dimensional space around the nucleus where the probability of finding electrons is maximum. That structures are called orbitals, and these structures can be drawn by calculating the value of wave function, which Schrödinger calculated for every orbital, and these values are when plotted with the distance from the nucleus, then they give particular values for these diagrams, and on the basis of that specific shapes can be observed, which are called boundary surface diagrams of orbitals. Actually, probability of finding electrons doesn't become zero even at large distance. So it is not possible to draw a specific shape. Rather, those areas are selected where this probability is maximum. So this is how these shapes were obtained. Firstly, Schrödinger plotted these value of wave function psi with respect to the distance from the nucleus, and he observed for 1s orbital the electron density, or you can say wave function, is maximum near the nucleus, and with increasing distance from the nucleus the value of psi decreases. For 2s orbital it is lesser, and then it starts increasing again when we move away from the nucleus. And for 2p it is 0 near the nucleus, then it reaches to a maxima, and then it starts decreasing. And one more option, that is psi square, which is used to describe the probability of finding electron when plotted against distance from the nucleus. Then also we get the curves. Actually these curves are different for different orbitals, so that is how the shapes were obtained from these curves. So for 1s orbital, psi square also maximum near the nucleus, then it starts decreasing. For 2s, first it near the nucleus it becomes lower, and then it starts increasing up to a maximum value, and then further starts decreasing. For p orbital it is 0 initially near the nucleus, then it reaches up to a maximum. So in the form of distance, when we observe these values and when we plot this kind of structural figures, then those boundary surface diagrams are obtained. So as you can see in that particular curves, sometimes the region or you can say sometimes the value of psi or psi square approaches to 0. For those regions where this value of probable density approaches to 0, those areas present in orbital is called a nodal region or a nodal plane. As you can see here in 1s, there is no such region where the electron density is less. So this has no nodal region, whereas in 2s and 3s you can see that white area around the 1s. When 1s and 2s, in between 1s and 2s orbital, there is a region where electron density approaches to 0. So this region is called nodal region. And here you can see in p orbital, between two lobes a plane is there where electron density is minimum. So this is also kind of orbital nodal plane. So a region or a plane where the probability of finding electrons is minimum or approaches to zero is called a node, and number of nodes present in an orbital is always equal to n minus 1. तो with increase in number of n, principal quantum number जितना ज़्यादा होगा उतने ज़्यादा ही nodes present होंगे. These nodes are of two types, as we have seen. One is a kind of spherical region and another is a kind of plane. So spherical or radial nodes are the nodes which are present in a three-dimensional region around the nucleus where the probability of finding electron approaches to zero, and number of radial nodes in an orbital can be calculated by this formula n minus L minus 1. For example, as we can see, 1s doesn't have any spherical node, but 2s has one node because 1s की जो बाउंड्री जहाँ पे मैक्सिमम इलेक्ट्रॉन डेंसिटी है उसके बाद जैसे इलेक्ट्रॉन डेंसिटी डिक्रीज होना स्टार्ट होती है वहाँ पर हम कह देते हैं कि नोड आ गई है. उसके बाद अगेन जब इलेक्ट्रॉन डेंसिटी इंक्रीज होती है देन 2s ऑर्बिटल कम्स. तो बिटवीन 2s एंड 1s ऑर्बिटल देयर इज वन नोड. नाउ इफ वी कंसिडर स्ट्रक्चर ऑफ 3s ऑर्बिटल, तो 1s एंड 2s के बीच में एक और 2s एंड 3s के बीच में अगेन वन नोड विल बी देयर. तो 3s ऑर्बिटल विल हैव टू नोड्स, टू रेडियल नोड्स. सिमिलरली 2p orbital doesn't have any node because it is the closest to the nucleus, but it when we approach or when we consider 3p orbital, then there is some region between 2p and 3p, then there exists one radial node. So in this way radial nodes are present when a new orbital starts. And second type of nodes are called angular nodes or nodal plane. These are actually plane which are passing through the nucleus where the probability of finding electron approaches to zero. So this type of nodes are present when orbitals have some other kind of shape as compared to spherical. For example, p and d orbitals, they have double dumbbell or clover like shape. तो उनकी shapes के बीच में इस तरह के planes आप देख सकते हो. In p orbital there is one nodal plane, in each d orbital there are two nodal planes. So these are actually planes around which electron density is approaching to zero, and the number of radial nodes in an orbital is always equal to the value of L. Suppose p orbital के लिए value L की क्या होती है? It's 1. So it will always have one angular node. For d orbital value of L is 2. So it will always have two orbital angular nodes. Now we'll consider shapes of s orbitals. S orbitals, because the value of L is 0, so they are spherical in shape as we have already discussed in quantum numbers. So s orbitals are spherical in shape and their electron cloud is symmetrical. As you can see here in x, y, z, all three directions, the electron cloud is symmetrically distributed. Hence these orbitals are non-directional, मतलब किसी भी एक particular direction में oriented नहीं है. They are symmetrically distributed in all direction. And with increase in number of n, you can say the size of orbitals increase. For example, 1s is smaller, then 2s is larger than 1s, 3s is more larger than 2s as well. And as we have already discussed, no node is present in 1s, but one radial node is present in 2s and two radial nodes are present in 3s. Because of the symmetrical distribution around the nucleus due to spherical structure, there is no angular node present in s orbitals. Next is shapes of p orbitals. P orbitals are dumbbell in shape, means dumbbell shape type के इसमें two lobes होते हैं which are actually the electron cloud is distributed in two lobes symmetrical about a particular axis. एक particular axis पर वो दो lobes present हो सकते हैं. For example, when they are present in along the x-axis, then those orbitals are called px orbitals. If the electron density clouds are present along the y-axis only in the form of two lobes, then the name of these orbitals are called py orbital, and if they are along the z-axis, then those p orbitals are called pz. So on the basis of three possible orientations, each p subshell has three p orbitals, and which are designated as px, py and pz. And collectively, all these three orbitals are present, as you can see the fourth diagram, in x, y and z different directions. So these are the shapes, you can say, or the probable region where the finding electron probability is maximum. So if we go to the next p orbital, means abhi to hum ye 2p की shape देख रहे हैं, if we go to 3p, then again the size will increase but the shape will remain same. So for every type of orbitals with increase in quantum number, size, principal quantum number, size increases. So let us see how these s and p orbitals are three-dimensionally arranged in an atom. So this is one s orbital nearest to the nucleus, means lesser the value of n, closer would be the orbital to the nucleus. And then it is 2p, 2s, and then 2px along the x-axis. Then here comes 2py along the y-axis. And next we have 2pz along the z-axis. So in this way you can say that the atom is a three-dimensional structure having electron clouds around the nucleus in a probable density. So these are actually not specific rigid boundaries. They are just the probable boundaries where the electron finding probability is 90 to 95%. So these are the shapes of s and p orbitals. Next, how many nodes are present in p orbitals? As we had discussed that in p orbital, each p orbital has a dumbbell shaped structure. So between two lobes of that dumbbell, there is a plane. As you can see here in first figure, between two lobes there is a plane shown by these dotted lines, where the electron finding probability is approximately 0. So this is called an angular node. So each p orbital has one angular node, and first जो 2p orbital है, which is closer to the nucleus, it doesn't have any radial node, but 3p orbital will have one radial node. Similarly, 4p orbital will have two radial nodes. So number of radial nodes increase regularly, whereas number of angular node will remain same, that is 1 in all p orbitals. Otherwise, total number of nodes we can calculate by the formula n minus 1. Next is the shapes of d orbitals. So d orbitals have clover leaf like shape, as you can see here in the figure, and as you know that d orbitals have value of L, azimuthal quantum number 2. So for L2 we have 5 orientations possible: -2, -1, 0, +1, +2. So for these 5 possible orientations, each d subshell has 5 d orbitals, and according to their orientations, these are designated as dxy, dyz, dxz, dx square, y square and dz square. As you can see here, this is because of the presence of the 4 lobes of these d orbitals in particular axis. For yz, as you can see here, the density, electron density cloud is not present near the x-axis, rather they are present only in between the z and y-axis. The name is given dyz. For dxz, no electron cloud are present near the y-axis or along the y-axis. They are present in between the x and z-axis. The name is dxz. For dxy, x and y एक्सिस के बीच में आपको इलेक्ट्रॉन लोब्स नजर आएंगे, z एक्सिस के लॉन्ग या उसके आसपास इलेक्ट्रॉन डेंसिटी नहीं होगी. It would be approaching to 0 in that particular direction. And dx square y square, जो ये 4 lobes है, they are exactly along the x and y axis. इन बाकी तीनों में बेटा along नहीं एक्सेस के, दे आर प्रेजेंट इन बिटवीन टू प्लेन्स, एक्स एंड वाई के बीच में होगा या एक्स एंड जेड के बीच में होगा या वाई एंड जेड के बीच में होगा. बट इन दी एक्स स्क्वायर वाई स्क्वायर इलेक्ट्रॉन क्लाउड्स आर along the x and y axis. And last dz square is a such different kind of shape in which two lobes are present around along the z axis and a ring is present in the plane of x and y axis. So let us see the animation of these structures of. दिस इज हाउ डी एक्स एंड जेड, एक्स और जेड एक्सिस प्लेन के बीच में वो आ रहे हैं, अलोंग दी एक्सिस नहीं है. फॉर डी एक्स वाई यू कैन से एक्स और वाई जो प्लेन है उनके बीच में इलेक्ट्रॉन डेंसिटी है 4 लोब्स की फॉर्म में. फॉर डी जेड वाई जेड और जेड वाई यू कैन से, एंड फॉर डी एक्स स्क्वायर वाई स्क्वायर एग्जैक्टली अलोंग द एक्सिस, एक्स एंड वाई एक्सिस के अलोंग. डी जेड स्क्वायर दो जो लोब्स हैं वो जेड एक्सिस के अलोंग है, रिंग जो है वो एक्स एंड वाई एक्सिस के अराउंड है. तो इन दिस वे दीज आर द 5 स्ट्रक्चर्स ऑफ दीज डी ऑर्बिटल्स. Next we can have a look how this dz square has a different shape. Here you can see that z axis के along आपको 2 lobes नजर आ रहे हैं and 1 ring around xy plane. तो in this way electrons revolve in these lobes as well as this ring. So this is how the structure of dz square orbital. So in this way we can say 4 d orbitals are similar in structures having 4 lobes, whereas 1 d orbital, which is dz square, it is somewhat different in shape, having 2 lobes and 1 ring, where the electron cloud or electron probable density is maximum. Now we can see the nodes, number of nodes in d orbitals. As 3d, which is nearest to the nucleus, you can see here in the second figure, 3d orbital is closest to the nucleus, so it will not have any radial node. उसके बाद तो 3d और 4d के बीच में जो स्पेस आ जाएगा जहाँ इलेक्ट्रॉन डेंसिटी अप्रॉक्सीमेटली 0 हो जाती है, दैट इज फर्स्ट रेडियल नोड. तो 3d ऑर्बिटल विल नॉट हैव एनी रेडियल नोड, बट 4d ऑर्बिटल्स विल हैव 1 रेडियल नोड एंड 5d ऑर्बिटल विल हैव 2 radial nodes. So these are how radial nodes increase with increase in number of n. Whereas angular nodes are fixed for every d orbital, whether it is of any shape. There are actually 4 lobes. So in between these 4 lobes, you can see 2 planes are there along which the electron probable density is 0. So that 2 nodal planes are called angular nodes. So each d orbital, whether it is 3d, 4d, 5d, 6d, they all will have 2 angular nodes, but radial nodes will vary according to the number of n. Principal quantum number जैसे increase होगा, radial nodes will increase. I hope the shapes and the nodal region are clear to you all now. So try to solve the assignment. Thank you and have a nice day.